Alright guys, welcome to your third video on how to pass trigonometry. In this video we're going to be talking about coterminal angles and how to find the coterminal angles when you're given another angle. So let's start out defining a few words here. Determine the measure of the positive angle with a measure less than 360 degrees that is coterminal with the angle given. Then classify the quadrant. All angles are in standard position. When you're looking at a word chunk like this, it can be a little bit complex. So I find it helpful to underline the important bits. Less than 360 is a little bit important. The really important ones are coterminal, quadrant, and standard position. So let's go ahead and define a few of these. And I'm going to try to stay within my green box here and keep a little more organized than I normally do. I have here a set of axes with standard position is basically just 0 degrees, where we can also label this as 90 degrees, this as 180 degrees, and then this point is going to be 270 degrees. Then, if we want to classify the quadrants, it's as simple as quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Didn't really leave myself enough room right there, but you get the picture. So, if then solving for a coterminal angle, let's go ahead and use an example of angle theta equals 610 degrees. I don't know why, but everybody likes to use theta. Maybe it's because it's a lot easier to draw than the other Greek symbols, but I like theta as well. So 610 degrees is basically this. Starting at standard position, we go around and we hit 360 degrees. So after being 0, if you go all the way around, this is 360 degrees. And then you keep going until you hit 610 degrees, which is about here. So we've made one full rotation, and then a half, and then a little bit more. Well, basically, to find the coterminal angle of this degrees, what we want to do is this guy, he traveled all of this distance, but he wants to take a shortcut to get back to standard position, and he doesn't want to have to go back all the way. So we want to find the shortest amount of degrees from this point, going back the path that he came and getting back to standard position. And so it's pretty simple if you think about it. In order to get back, he's at 610, and we can just subtract 360 from the 610, and we get 250 degrees. So that's the coterminal angle when the angle you're given is 610. So, I mean, finding coterminal angle is pretty easy, right? Well, let's try one other problem. So if I go ahead and draw another set of axes over here, let's just pretend that we have another angle, and this one is going to be theta, and it's going to be negative 3,789. So looking at the negative property, we know that he's going to go the opposite direction. And we also know that he's going to travel quite a bit farther than just one rotation or two rotation or even three rotations. And so there's actually a formula in order to solve the coterminal angle. That formula is basically you start out with the angle you're given, and you set that equal to x, or a degree amount, which is going to be the coterminal angle, plus an integer, which is the amount of times that you will end up going around, the amount of rotations, and then you multiply that by 360. And this integer is also, if you go positive, it's going to be a positive integer. If you go around in a negative way, then it's going to be a negative integer. So let's go ahead and plug in what we know. Well, it's going to take a while for us to go around and count all the degrees and add them up. So really simply, all we need to do is divide this by 360 degrees. And that will give us how many times he goes around. So I did that in a calculator, and to get the most accurate answer, I got 10 rotations and then 0.525 more after the 10th rotation. So what I have here is negative 3789 equal to, I don't yet know what the coterminal is, that's what I'm solving for, but I do know that he's going in a negative direction 10 times, and then I can multiply that by the amount of rotations. So if I go ahead and do the math here, then I know that this is negative 3,600. So I'm just going to go ahead and I'll go ahead and write this out here. Negative 3,789 is equal to x degrees minus 3,600. So then if I just do the algebra, I can add this over here, and then these two cancel out to equal 0. And then if I add it over here, then I get a negative 189 degrees, which just so happens to be the coterminal angle. Well, I'm left with 189 degrees, but I haven't yet classified what quadrant I'm in. So this being the coterminal angle, I can go ahead and say, well, if that's how far I've traveled, then let's start at the coterminal and let's go around 189 degrees. So if I go to there, I know that's 90 degrees. If I go there, I know that's another 90, which is 180, which means I only need to go 9 more degrees, which is just a little bit right there. So that's going to be my quadrant that I'm going to be classifying. So that's quadrant 1 and quadrant 2. So basically, if you have a really simple or a smaller degree that you're working on to find the coterminal, you can go ahead and just subtract 360, or if it's going the opposite direction, add 360 to get your coterminal. But you're going to really want to learn this formula so that whenever more difficult problems arise, you will easily know how to handle it. And any test problems that come across, you'll be able to ace like a boss. So I hope this made sense to you guys. And go ahead and leave a comment if you have any questions. And yeah, so good luck, and I hope to see you on the next video on how to pass trigonometry.